first category we're going to take a look at is Endo Tet. Now, if we interpreted Baldwin's rules a little too literally, we might wrongly say that Baldwin tells us that Endo Tet do not happen. It's a little more complex than that. In fact, Endo Tet in reality are merely rare. So now we're going to see some exceptions to Baldwin's rules, because Baldwin only ever claimed they were generally unfavourable. They're not, however, always unfavourable, and that's an important distinction. In our first example, an alcohol is attacking a functional group called a cyclic sulfate. We can see the ring that forms has 5 atoms in it. The cyclic sulfate involves both carbons 4 and 5 of that ring, and the bond breaks between carbon 5 and its corresponding oxygen. Therefore, it's an internal bond that's breaking here. Last part of the observation is that carbon 5 is a tetrahedral carbon, and so we call this 5-endo tet, and this reaction does actually happen. Here's another example. Again, we have an alcohol, this time attacking an epoxide. We form, as a result of the reaction, a 6-membered ring. The epoxide is partially made up of carbons 6 and 5 of that ring, and we break the bond between carbon 6 and its corresponding oxygen. So the bond we're breaking is an internal bond. Carbon 6 is a tetrahedral carbon. When we bring all that information together, we will see that what we have here is 6-endo tet. And again, the reaction does occur. But why does it occur? Well, the really key part of this molecule is the double bond, the alkene that's here. It's the pi orbitals that act to stabilize the transition state of the molecule. The pi orbitals align with the bond that is partially breaking and also the bond that is partially forming. And this allows for a lower energy transition state, allowing ultimately the product to form. Let's look now at a very similar molecule. If you don't look carefully enough, you might think it's the same molecule. But notice, in this case, we have an alkane instead of an alkene. And let's see what the reaction is that happens here. Well, the ring that forms has 5 atoms in it. So there's a change straight away. The bond that's being broken is part of the epoxide, and the epoxide is only made up of carbon 5. Notice that the ring doesn't have a 6th carbon here. So therefore, when that bond breaks, it's an external bond that's breaking, and that's an important difference. Lastly, carbon 5 is tetrahedral. So what we have is 5-exo tet. So you can see now that when we get the 6-endo tet reaction, that alkene is absolutely critical for that to happen. Normally, 5-exo tet will dominate 6-endo tet, where there's a choice within the same molecule.